Huh. Yeah,
I
I think
don't.
we are live.
Oh, one sec. The YouTube
Are
stream
we?
is not. Can someone else check YouTube? Okay, yes, we are live.
Oh, we're live?
Yeah,
You're
I think
live?
we're
Okay.
live.
Hello, everybody. Yeah, I think we should just
Yeah,
start.
we're live.
Oh, okay. What is 1?
All right.
Okay, so to me, A seems trivial because n will divide 1 to n sum.
I
Okay,
thought
guys,
we
we are
were
live.
actually for
Let's explain. Let's start with problem 1.
Yeah, so problem 1, A is easy. It's trivial because n divides the sum of first n numbers because n is odd. So you can't do it.
So has it started?
And
Has it started?
yeah.
Hello,
I
Vamsi, it has.
think so. It has started.
okay, what do you do for B? You want to prove that there is a nice rearrangement.
Definitely a construction.
Okay, are the questions visible to the audience properly?
So
Can
is
you
it
put
something
the
like you just keep doing it while you can? Yeah, I think that works, right? You just keep doing it while you can, and then in the end, you're safe as well. Does that work?
If you just pick
You want the
individually
first two things to
numbers.
add to an odd number. And then non-multiple of 3.
I think something like
All right.
Can't you just incrementally do it? Like each time you can add something, just add it. When will you get stuck? You only get stuck if you have
you don't
everything
have a choice,
congruent.
right? For large numbers, you might not have a choice.
Okay, so just induct, right? Like n minus 1 and n, remove that, do it for the others, then add n and n minus 1. That works.
Yeah, so basically
In
just swap
reverse
pairs.
order.
Yeah, like
Okay,
two.
Yeah, no,
so
this
for
works,
each
na?
odd number, you will
You can just
have
pair up. Something
1
like
plus
this.
2 plus all the way to n minus 1 plus n plus 1. Yes.
Yeah, so just do something
Yeah,
like
that's
2k,
it.
2k minus 1
Yeah.
for
This should
1
work.
to n. Yeah,
By
that
2.
works.
Yeah.
Okay, yeah, this works. And proof. Okay, for proof for even
Proof is
numbers,
easy
it's
for even
trivial.
ones. For the
Even
even
it's
ones,
easy.
obviously can't
And
work.
odd, it works.
And then for
Odd is
odd
just
ones,
one
it
more.
again can't work.
It's a desired sum plus 1.
We're shifting
Yeah.
by
Yes.
1, right? Yeah.
Perfect.
Okay, so that does 1.
First is 1.
Now let's move on to 2. What is 2?
Fix the positive integer n. Let me see the problem properly.
The problem is like so hard to read.
Let
Okay, I'll
Rn be
read it
the
out.
sum.
So it's
So
like
the problem
sum
says
of
that
n mod I, right?
that has to be
Yeah.
equal to n
Summation of
minus
n
1,
mod I.
which is interesting because that tells you a lot, right? That tells you that n is divisible by exactly, okay, it's divisible by n. So that means n has to be congruent to 1. Wait, what?
Wait,
If
what?
this is r, then you're just counting r, say like tau of n minus r times. Isn't the sum just this?
What? How?
Okay, yeah.
Yeah.
Like if the
Okay,
remainder
right.
is r,
I mean,
you're
not tau of n
counting.
minus r, not tau of n, because it should be I should be less than n minus r.
Okay, right.
Okay, is that automatically set?
But like that's automatically ensured, right?
But
So
r
we're
should be less than
like
I. R should be less than I.
Shouldn't n mod I be much bigger than n minus 1, like the sum in general?
So it's like bounding argument. Is there any number that works? I mean, 2 does
Right.
not
I
work.
think I have a feeling 12 and 6 will work.
12 and
6.
6.
Let's try 6. I think 6 might work. So 1, 2, 3, 4, 5, 6, right? For this, it is 0. For 0, 0. This is 2. This is 1.
No, this is too small.
And,
Oh, it doesn't work.
Let's
small.
do 12.
Let's do primes. Okay, primes is
Primes is too bad.
Primes will be
It's
too
just gonna
big.
be
Yeah. Whatever,
Yeah.
something like 7, so that n minus 1 has lots
R
and
of
lots of
7 is 8.
factors.
R of 7 is 8.
R of 7 is 8. It's too much.
Yeah, they
Yeah.
give it.
Okay. Just keep going for cases, I guess.
Yeah.
R of 5. R of 5
Wait.
is 4. R of 5
okay,
is 4.
look at numbers close to like slightly bigger than n by 2. You should have a very big remainder, right? So like if you have n is odd, you can just look at the number, say k plus 1. You get a remainder
No,
of
so
k.
in fact, what you can do is you can just look from n by 2 to n. Each of these will contribute at least n minus I. So you already have n squared. And so we have finite n, and then you can check.
Yeah,
Okay,
so
At
I
least
think
n
it's
minus I?
passing, right?
checking.
Like just look at the upper half.
Okay.
That must have a pretty big remainder. Like all of these should be pretty big.
Okay, let's make that formal. So let's fix k equal to ceiling of n by 2. Okay, not ceiling of n by 2. Let's do floor of n by 2 plus 1.
But no, seal. Okay.
Okay, yeah, that's
And
fine.
now
Yeah, so this
n
one.
mod k is at least n minus k, right?
Yeah.
Because
Yeah.
k is at least
It is n
and
minus k.
now the sum is
It
just
is
going
n
to be
minus k.
n minus I from I goes from k to n.
Yes.
This is equal to, what is this equal to?
NK
thing
minus
It's just the
no,
sum of
shit, bro.
1 all the way till CL of n by 2.
Yes.
But isn't it like slightly
No, CL of n by 2
by 2
minus
minus 1?
Minus 1. C n by 2 minus.
So that's equal to CL of n by 2 choose 2.
And
And
this
this is
is
equal to n
That
minus 1.
is, this
is
is equal to n minus 1.
at least
So we have
almost
n
n minus
minus
1.
1 is at least n by 2 choose 2. And I think for n equal to 12, this fails, right?
12
So
Well,
n
can't
is
be.
at n
No,
is at
it
most
doesn't
11.
fail. It doesn't fail for 12. 6 choose 2 is 15.
15. So it
It
fails.
fails.
Okay, yeah, Lama. I'm sorry, Lama.
Yeah.
Yeah,
Okay,
so
so we
n
need
is
to
at
check
Probably
most
one.
11.
fails for the smaller numbers.
Does it fail for 10 also?
It fails for 8.
Okay, perfect.
No,
So
no,
we
It fails
have
for
not
10
for
as
10.
well.
10, yeah, 10.
It fails
not
for
8.
10 as well.
10. Okay.
For 10, it's
So
like
you have to
9
check
at least
until 1
work.
to
9
9.
and 10.
5
check till 1
works.
to 9. Shouldn't be bad. Shouldn't be bad.
We leave this as an exercise to the readers.
The readers.
Viewers.
Viewer.
Okay. 1 to 9. Let's quickly check 1. 1 is, yes, 1
One is
works.
hard.
Okay, 2. No.
2
2.
is
No.
2 doesn't work.
Yeah,
3
2
does
is-
not work. Because
3.
we have one for 3. Does not work.
3 doesn't work either, right? Yeah.
Yeah.
Okay, RF3 is 1. RF4 is also 1. Does not
We know
work.
I think
it's
4
1.
works.
No, it's given 4
No,
is 1.
4 doesn't work either.
It's
5.
given in the question. We can't dispute. 5 works. RF5 is 4.
Okay. 6.
6, as we proved
we
earlier,
just
it
We
does not
check
work.
doesn't work.
Checked.
7.
7, we are given it.
R7 is
it
8.
doesn't work.
R7 is 8. Because, okay, do we show that?
I mean, it's
No,
shown.
it's
R7
given.
side is
It's
shown.
done. It's done in the.
Question itself.
Alright.
Okay, now we need to do for 8. So for 8, it's
Okay,
like.
let's do 8.
Just let's write down beneath the table over there. Remainders are 0, 0. Oh, it's already 1.
For 1, it's 0. For 2, it's 0. For 3, it's 2.
2, 4, it's 0,
For
5,
4, it's 0.
3.
For 5, it's 3. For
Oh,
6,
it
it's
is
2.
It
sadly
works.
adds up to 8.
Oh, 8.
Very
Almost
unfortunate.
there. Almost there.
Yeah.
Almost there.
Okay, now we need to check for 9.
9.
I think 9 will work maybe. Okay. What is 9 mod 1, guys? It is 0, 1, 0,
0.
1,
4.
4.
3, 2.
Oh,
Okay,
that's
so
too much.
3.
Too much.
10. 10
Too
is
much.
too
Okay,
That's what
9
we
itself fails. 4 plus 3 plus 2 plus 1. Okay,
Okay,
yes.
so the only answer is
1 and
5.
5. And
And
1
one.
and 1.
1 and
And
5.
1
Yeah,
and
1 and
1.
5.
1 is
Okay,
very
so 1 and
important.
5 seems to be it. We should probably check chat at this point and see if we've made some dumb errors here. Does anybody have other answers or something?
Someone
missed
said 1
something?
and 5. Congratulations.
Okay, so I think we're fine now. Let's go for 3 now. 3 is Geo.
Oh my god.
Hello, people. We have a beautiful
I'm-
constant of 23.
What?
I'm
What?
drawing
It's
this.
23 in the
Oh,
problem. Also,
What?
Archit, isosceles.
Okay. Yeah, I'm too used to drawing normal.
Yes, you
This
have
isn't-
23.
Is this an ICANN problem or an RMO problem?
No, but I think it's like not, I mean, the final statement is like G lying on the incircle. So it's not something that, I don't know.
Oh. How?
That's-
What?
Okay, AD is
Yeah.
perpendicular to BC.
Wait.
OHG.
Okay.
Oh my
actually
god, what is
relevant.
this?
Why is
What is
What is
this?
abomination?
23? Why is 23?
I mean, all of the points are on one line, just bash, I think.
No. We
What
did
is this
that.
Prove the
abomination?
G lies on the
mesh.
incircle. Wow. Okay.
Okay, hold on. Let's try to do this in a morally
Synthetic
acceptable
way.
way. Like, yeah.
Yeah.
Oh,
Oh, G.
okay. We actually
That's
know
that-
ratios of many of these, right? Okay, G you
Okay,
just
Exactly.
the ratios right over here.
You know, OGH ratio. We want I.
We know the G ratio is 2 by 3 also.
I don't think
from
this
A
is
to
a
D.
very good diagram. Maybe like this looks like an
Yeah.
equilateral triangle.
yes, but that is correct. Wait, let me.
Maybe draw like
How do you construct ABC that satisfy this? That's a good question.
That might be harder than the given problem.
I think
it, like,
G line
very
on
tall?
encircle is like.
Okay,
so-
we have a bunch of length conditions, right? So you have
Yeah,
Like,
yeah, I
don't
think
even
Kanav is
care.
right. It'll be
Don't even
really
care
tall.
about B and C at this point. Let's just draw a single line from A to D, and B, C, and all don't matter because
That is true, but I'm still going to draw it.
okay. And for this thing, you have
This,
That
OD.
does
this
not
is
look like the
supposedly
centroid,
G.
but
It
fine.
does. It can pass as a center.
I mean,
We
AG by
have two
GD
length
is
conditions.
1 by 1.
This is 2:2.
Yeah, so nice.
Yeah.
Yeah.
No, I think as time goes on, I agree with April's idea, but we should just like make this a coordinate system on AD.
Yeah.
How
So
do we
let's
use O
call
and H?
A 0 and let's call D 100.
Oh.
Not 100.
Why
So
100? Like, at
Let's
least
call
make
it
it
Let's call
divide by
D 20.
3.
Let's call
Let's
D
call it
23 in that.
23.
Yeah,
Let's call
23.
D1. Okay. Now G is equal to 2 by 3. Right? What is O? O
Yeah,
is,
that's
let's
the
say,
issue.
K.
That's
H is, let's say, L.
Wait,
And then
no.
what is
K
G?
and L are related.
Yeah.
K and L are
So
related.
what is the relationship between K and L?
2O plus H is L, I think. 3G.
2
Yeah,
plus H is
Actually,
3G.
if you pick G
Yeah.
to be 0, the entire thing is gonna be simplified. Pick G
So
to be
2K
0.
plus L is 3, right? Okay, cool.
No, I think you'll have to do POP at A. So, like, I think A is 0 is better.
A is 0.
Yeah, 2K plus L is 2, not 3.
2K plus L is equal to 3.
No.
2.
Yeah, 3G
How?
is 2.
Wait.
3G is 2.
2K plus L is equal to 2.
Okay, yeah.
Yeah,
G
yeah.
is 2 by 3.
And then what? 2 times OD is 23 times HD. So what is that? What is that telling us?
Just POP at A.
OD is like
Maybe
D minus
POP.
O. 1 minus O. 1 minus K.
1 minus K.
Okay, 2
Yeah.
minus 2K is equal to 23 minus 23L. Okay.
Yeah, so now we can solve for K and L. I learned
And what's
this.
I? What's I?
Okay, we have simultaneous
21 is
equation.
equal to 23L minus 2K, right? Okay, so now we can just add. And I think this becomes quite good. You get
Wow.
24L is equal to 23.
L is 23, 24. It's okay, perfect.
Great.
Yeah, that's not so good actually. And then what is K?
25 by 24.
What is this?
I think,
problem?
wait, or am I wrong? No, 25 by 48, I think.
Yeah, yeah.
25 by
2K
48.
plus L is equal to 2, right?
Yeah.
Yeah.
So
Great.
2K is equal to 25 by 24. Correct.
Wait, so if we take the midpoint
Alright.
of R, L,
Ah,
then L is 25 by 24.
yes,
Wait,
that is
midpoint of
correct.
which
Interesting,
arc?
exactly.
Like BC, in circle ABC.
Yeah,
Because O is the midpoint of L, right?
Yeah.
yeah.
And Li is
Now power of point.
for
You want to prove
In circle is still not good.
we don't know I,
Yeah.
and we can't know.
Yeah, that's an issue.
I propose we trick bash.
Let's try it now.
Looks very power of point like only. Proves that find the power of G with respect to the ins. Okay.
But like we don't know
Okay,
nothing
that's
about
probably
this
well
circle.
known actually. Yeah, when does G lie in the in circle? Is there a condition for that?
Or can we find the coordinate of the incenter and then length slash IG to be ID?
Incenter would be like solution to a quadratic.
We want to prove that incenter is the
Yeah.
midpoint of GD in this case.
Ah,
Wait, that is very
Circle.
yeah. So we already have
Yeah,
calculated
right.
G, right? G is just 2 by 3 and this is 1. So what do we want to really show?
We want to prove that I is 5 by 6. Interesting.
So if you want to
Okay,
show
that's a-
I is
that's a
5 by 6, that
magical
tells you
target.
you want to show some relation, metric relation.
Okay, you have 25. I think that's very promising. Come on.
yeah, like 25 by 24, 23 by 24. It looks
That makes
good.
perfect
yeah.
sense.
Okay, also this should not be L. It should be something else.
All right.
Oh, you have the power of M with respect to encircle this.
Okay. Wait, can you do? We know capital R, right?
Capital R, yeah.
Oh, wait, no, sorry. Wait, that doesn't work. Sorry, I was like trying to calculate arc midpoint to I because we know arc midpoint.
AI time. Do we know AB times AC? We
Wait.
don't, right?
Archimede, what are we doing?
AB is equal
Bro,
to AC.
We know arc midpoint.
We know Archimede point, so MD times MA is MI squared.
Right,
yes.
right. Come on. Yes, exactly.
Mhm.
Yes.
Okay,
Yes.
arc midpoint.
Okay, that's actually very
I
good.
don't-
1
I
by
don't even
24
remember
times
that's
20 by
true.
24.
Yeah, arc midpoint is just reflection of A about O. And we know O
Yeah,
and A.
Yeah.
that's very nice.
Yeah,
Li
yeah,
is
done.
5 by
Yeah, I
24.
done. Yeah, done.
Yeah.
Done. Yes.
Such a
Alright,
depressing
wait, do
problem.
the numbers add up?
Yeah, they do. 25 minus by 24 minus 5 by 24 is 5 by 6.
4 is 20 by 24, which is 5 by 6. Okay,
Yeah, done.
thank you.
What is
Nice.
What a beautiful
Okay.
problem.
So we're done with the
23 is
IFM problem.
relevant.
Yeah. Fourth
23 is
one.
so done.
Yeah, 23 is like
Fourth
my
is-
favorite number now. Fourth one, I think I've even done with yeah, I've done this problem before, I think.
Okay, the
Yeah,
squares add up to
same. I also
1.
feel like I've seen this before, like exact same.
Like I think I've done this in INMO TC.
Okay, so if you just call
Okay, this
this
seems
like
Yeah, you can just put an order and like, wait, no.
and then this is like u plus 1 by root 5 at least.
Yeah. Okay, the worst case is like the middle point is 0. So like u is something like u plus, like the middle number is 0. That should be the worst case. Okay, just solve the quadratic right now. That should work out.
How much time are we at? We're 18 minutes
minutes.
into solving.
Let's try to do this in a cool way. That is like just some sums and all, and then it magically works out.
Like the 23, sure.
I propose we do this.
Just square it.
No, I
No.
propose we do
Some
this.
argument is less than.
I think this will
overall
work.
choices of I and J, of which there are, what choose two? 6 choices.
Yeah, but then you implicitly also use the order to your benefit to get j minus I
True,
naught
true.
square. And I think this will work because like this part is going to evaluate to something good, I think.
Why are you doing this? Why can't you just expand this? Just no.
What do you
Expand
mean?
this.
Oh yeah, can we
I
just
mean,
expand this? Like assume on the contrary, then we have A1 is equal to say 0, and then
Just sum
A2 is
this.
equal to 1/5, A3 is equal to 2/5, A4 is equal to
Why can you assume that?
It's not, they're real numbers, not non-negative.
real numbers, true. No,
So
so we
the-
start from
Real numbers.
So the point, like, you just take a quadratic and just expand this. Should work.
Quadratic.
Like, just look at this. This is at most 1. This should be false.
Wait,
Yeah,
where
no,
are
but
you?
that's not a cool solution though.
Sure.
okay, that's a very bashy solution over here, but
Okay, you can simplify things by
Can someone help me compute this sum? What is this?
oh, this sum is
It's not like we have the
well known,
summation
right?
AI AJ, which we don't know.
I think it's
Yeah, this
just
is
n
like-
times sum of ai squared minus
Yeah, summation. This is equal to this.
sum of ai whole squared, something like
Yes.
this, right?
Yeah.
Yeah.
Okay, I wrote it in the
Okay.
opposite one.
And
Okay,
minus
So you're being told that this is at least how much?
1/5 times the same summation for all ones. No, or 1 to j.
What is that?
1 square plus 2 square plus 3 square plus 4 square is
is 30.
30. Yeah, 30.
30. So this is at least
5 times
6, nah?
30.
And then
Wait, no,
This is
5 times
4.
30. We are not done yet. Wait. 5 times 30 minus 10 squared is 50. 50 by 5 is 10.
are you sure it's 10?
Yeah. Wait.
That seems how is equality ever going to hold?
I mean, like, do you
Wait,
expect
can
it
we
to-
find equality over here?
I mean, then we're done now. We're already done. We don't need to do anything else. We're done just by this.
Wait.
Alright.
It's not, okay, it's 5. It's 4, not 10. It's 4.
So then we're done. Then you just get sum of ai 0 or something, and then you're trivially going to.
Wait, how are you done? You want n summation AI square is
Like you have this now,
okay. I see.
and this is equal to like what? This is equal to 4, you said.
Okay, let's check it again. It's
Let's
4
actually
times.
compute
is
this.
4
this
times
a
30
1
minus.
square
construction
plus
of equality?
2 square plus 3
That's 30.
square.
This is 30.
Then you have 2 squared plus 3 squared, and then you have 3 squared, right?
What?
Aren't these just the cubes? 1 cubed, 2 cubed, and 2 cubed?
This is the sum, and this is equal to what? 1 squared plus 2 squared plus 3 squared is.
No, you can
Yeah,
just
we
do
can
1
do
cube plus
this.
2 cube plus
I am
3
done
cube
by
plus
the-
Good observation. Good observation.
and that is so the square is a triangle number. That's 36.
36. That's not.
That's
That
a
just
famous
works,
identity.
but
And
like,
it's not a multiple. Wait.
Interesting cube.
Wait. What is 1 cube plus 2 cube plus 6? 36, right? So it is at least
Yeah.
36 by 5. But on this side, it's at most 4, so we're done.
Wait,
Wait, that's a very crude problem. I'm pretty sure we.
Yeah, the bounds are not tight at all.
No, like the other solution just works.
It's not like
Equality.
23 problem. Like it will be something like
wait,
23.
it is 3 times 1 square plus 2 times 2 square plus 1 times 3 square. Like the
Mhm.
table is
Yeah,
it's
This is an equality case.
Ah,
And, like,
okay, yeah.
Just doing this
Yeah,
just
it's the other
works.
way around. We messed up. This is 1 square plus 2 square plus 3 square.
Wait,
1 square
does
plus
just
2 square,
expanding
and
the
that's it.
quadratic work?
How
Yeah,
much is
it
this?
just
This
works.
is
Like you just do slightly smartly and it just works.
Okay, let's
3
just
Like, it
plus
just
start from
has
the
to
top.
work.
wait,
3
what
plus
did you do
8
exactly?
plus 9. What is this equal to? This is equal to 20. So it's
Yeah.
like exactly 4 here.
And so done. And so equality is when
And so
summation
done.
is 0.
Yeah, equality has to be when the summation is equal, but then like we have strictly less than anywhere, because so we can actually make this strict and we have a contradiction. I like this better than expanding some quadratic and doing discriminants.
It is actually just like 4w square plus 1. That's what you get in the end. No discriminant.
Yeah, but this is cleaner. Like this is
No, how is that cleaner?
I mean,
That's just
ours
much
is,
easier.
I mean,
it has more aesthetic value, this other
Okay,
solution.
sure. But
Aesthetic
like
value.
the first one's like absolutely dumb and just works.
Okay, so I think we're fine here. I think that does 4. Let's go for 5 now.
Maybe we should move,
Okay, hold on.
like
Let me
copy
take a
the paper
screenshot
down.
and
Yeah.
move it as
Yeah.
yeah.
Okay, there's
Because,
one
like,
more
we need
length.
to be grounded.
Okay, hold on. Yeah.
Really love
Okay, so
lengths.
let me draw the diagram. AB is a cyclic quadrilateral where it's parallel, so it's an isosceles
Isosceles
trapezoid.
Maybe parallel to BD.
And you have
Why
AB less
didn't
than
they just
CD?
call
Okay,
it
they
an
didn't say anything.
isosceles trapezoid? Very weird.
Point on AD.
Let O be the circumcenter of ABCD. All right, cool.
Just midpoint.
Let L be the point on AD such that OL is perpendicular to AD, so it's the midpoint.
Okay.
What is this?
Why?
Call it that.
OB into AB plus CD is OL into
What
AC
is
plus
this
BD.
problem, man?
What?
You want
Why?
to show R into AB plus CD. So I propose we do a trig bash.
But
No,
wait,
let's-
do synthetic.
Why? No.
This is probably a very nice, synthetic solution, but
I think
OL
that's
is
going to
square
be
both
sine of
sides.
alpha plus
Okay,
beta
okay.
equal to something. Like I'm actually telling you, it's just straight up going to be that.
trig
Let's
bash
square
does
both
not
sides.
work.
I claim this is the identity sine of alpha plus beta plus sine of alpha minus beta equal to 2 times something. Probably in the end.
Trig
And
bash
the
is going to
R-
work.
AC
like,
plus
Stop,
BD. Yeah, AC
stop.
plus BD.
Wait, wait, what was
Okay.
Ptolemy again? Like,
AC into BD is AB into
Ptolemy will
CD
introduce a
plus-
lot of unrelated terms also.
No,
and
actually,
also
Ptolemy
we
might
have to
not
work
be
with the
bad.
isosceles trapezoid. Abhi.
Ptolemy
Or
might
should we
not be
square?
bad.
Should we square
We
this
have to bring
terms?
it.
Why are we not
maybe-
trig bashing? I don't get it. Why do you have to be like
See, Ptolemy gives you this, and squaring also might be good. Because you
Yeah.
have AD squared, and then that also relates to like R squared as well. Because you can
Yeah.
write AD squared as like OS
Mm.
squared, 4 times OS squared minus OL squared.
Into 1 squared is like. Okay, maybe this is not very.
I think we should just trig bash. Is anybody interested in completing the trig bash?
I'm interested
That
because I'm more
seems too
interested in
sad
synthetic
for
solution.
life solving. It's just
Okay, so
depressing.
let's assume this angle is alpha.
Bro, you
No,
actually
please.
click bashing.
And-
Please don't.
No, please.
Please.
And let's say this is
Arshit.
beta.
Arshit, please.
Now
I should
AB is
know.
equal to 2R
No.
sine
But
beta.
AC is BD. Why did that?
right, AC is.
That's a part of the computer. And
Oh yeah, I told you 2 times. I told you.
Wow.
why
I
was
told
the
you.
AC plus BD?
Yeah, as time goes on, I'm more correct.
Okay.
Maybe we
very,
should-
very scuffed
Maybe we
RMO.
should just trig bash.
Yeah, I think you should trig bash. Like this is literally just that. Like if you
Yeah,
unpack
yeah.
it.
It probably is. Yeah.
So like the sine truth ones.
Yeah.
Mhm.
Yeah, okay. So AB is equal to 2R sine beta. What is AC? AC is equal to 2R sine alpha plus beta.
Yeah,
Okay.
I think that works. I think that should work.
Yeah. AB plus CD, how much is that?
Wait,
AB
what's
plus CD
DC?
is like
What's
What-
DC?
Okay.
CD
Oh,
is
and then this is also alpha. AOL is also alpha. So
Yeah,
that
but
is
we must need CD. Wait.
we need CD. We need CD. Wait.
Okay, CD is 180 minus 2 alpha.
CD,
Okay, 2
yeah,
r sine
like
alpha
this is
plus 2 alpha plus beta.
Yeah, CD is 2R sine
2 alpha plus
2
beta.
alpha plus beta.
Because ACD is alpha.
Yeah.
yeah, let's go. It's happening.
Okay, it finishes.
Okay,
Okay,
yeah,
Archit
we're done
is
now.
wrong.
Lama.
It finishes.
Okay, so
right?
yes,
It's literally what you said.
cool. Yeah. All right. So now we're done with 5 as well. Now let's
Do you
move
want to
on
like write it
to.
down entirely?
Like just at least
No,
write
no,
it
we,
down
we
for the
need we
entire
need to
license.
be a little rigorous
Okay,
about
fine.
it.
Yeah, fair.
2
Okay,
times.
so we observed that if we call this alpha and this beta, you can chase this. Oh, wait.
We get cos. Okay, yeah, we should get cos.
Yeah, you
We
get
use
cos.
cos alpha.
Cos
Cos
alpha and
alpha.
then
R cos alpha.
And AC is
Yeah.
sin alpha plus beta. This
And
is
this is
right.
literally the
Okay.
Yeah.
identity. So yeah, done.
Okay, cool. So with this, we are done with 5 as well.
Okay,
And now
it's
we can
probably
move on to
Beautiful.
6.
Yeah, I'll
6.
post 6. I'll post 6 here.
Are you? Okay.
Oh, okay.
Very high quality.
Yeah.
And
Maybe
Call a
this
sequence
will be a
of positive
positive
integers an
integer.
n chain if, okay, interesting.
it divides.
Let f of n be the number of n chains, and you have to count the number of n chains.
Okay, that's last number is n.
This is just induct. Okay, so
Yeah,
let's
it
first
is just
calculate
induct.
f of 2 to the power n.
Can't
F
we
of 2
just-
to the power n is 1, right? So f
Yeah.
of 2 to the power m times 3 is equal to f of 2 to the m minus 1 times
Hmm.
3
Wait, f of 2
plus
to the n
f
is
of
1.
2 to the m.
Wait, why is f of 2 to the n 1? F of 2 to the n is
Oh,
going
no,
to
no,
be.
no. K can be
You have
anything.
f
Arshad.
of-
Yeah,
Ah,
K
yeah,
can be
I
anything.
realized.
Anything.
It's not necessarily a prime that goes in.
So it's like you
Like
choose.
it's just a very multiplicative structure, right?
Yeah,
It's
exactly.
going to be 2 to the n minus 1. F of 2 to the n
It's
is 2
going
to
to
the n
be
minus 1.
m plus
Like f of 2 to the n, you can
f
build up
of,
an
It's 2 to the n minus 1. It's just 2 to
Yeah,
the
it's
n
2 to the
minus
n
1.
minus 1.
it's this, right?
Yeah.
M. What's M?
And what f of 3 is like 2.
Just use the induction right there.
Wait, what's M
Somewhere
here?
like-
F of 2 to the n is 2 to the n minus 1. Yeah, not 1.
Wait, why are you adding an m out here?
Yeah, I mean, he thought it was 1. It's not 1. So
Oh,
it
it's not
becomes.
one.
How is
It's
f
not
of
1.
3 2 though?
This is 2 to the n minus 1, right?
Wait, no, it's the summation of 2 to the n
Oh,
minus
it's
1 for all the
summation 2 to the n
small
minus 1. Right. This is basically just write it as like summation f of 2 to the n.
No, f of 3 is unfortunately 1.
Okay, yeah.
Wait, f of 3 is 1?
F of 3 is 1.
Yeah.
Why is that unfortunate?
Okay, no, it's even more fortunate.
No, f of 3 is 2, right? You can have 3
This
and you
is
can
1
have 1
3.
and 3.
So that's the start with
Ah.
1.
Equal to.
The
Oh
start
no,
is
you
always 1.
need n at least 2. No, I think they're just scamming here.
No,
we
no,
should,
no.
We should probably not accept
No,
that.
you start with 1
Wait,
and
yeah, I'll
like
start
the
with +1.
sequence length is anything.
Yeah,
No,
so
wait,
let's
No,
let's
the
let
sequence length is
let's
anything.
Let's slow
But it
down.
has to
Let's slow
end in
down.
n.
Let's wait.
Let's slow down.
This
There is no
identity is
+1.
right, right? Is this
Okay, but we
identity
need to
right?
restart.
There is no +1.
There is a
Wow.
+1. Just 1 and
No.
n.
we have this, right?
Okay, 1 and n. Yes, my bad.
Yeah, just 1 and n. Wait, no, it is.
Okay.
So f of 3
This
is
is
2,
Yeah.
the
right?
recurrence,
And d
right?
greater than 1.
No, f of 3 is 1.
Why do you need d greater than 1?
I mean,
So
f
Why
of 1
can't it
makes
be
sense.
n and then 1?
Yeah, that is counted here.
That's this case. So let's
No,
just define
that
f of
case
1
is
is equal
just
to 1.
n.
No, that
that
can't
case is
happen.
No,
just
That
just n
can't
can't
happen.
exist.
1
You're
and n
supposed to
should
start
be.
with 1. Let's just define f of 1 is equal to 1 and like remove the d
Okay,
greater than
I
1.
mean, then the power of 2 identity fails. F of 2 is also 1.
No, we don't need any
Fair enough.
induction sort of thing to even go here. So, like, if you have
Why?
f of 2 to the power m times 3.
I propose we see this as paths. So like we should
Yeah, we see
Wait,
this
we've got
path in the
done
graph.
then.
Exactly. And you have a 2 into m matrix, okay? In a
yeah,
2 into
exactly,
m
exactly.
thingy, you have 1 here and 2
So
to
you
the
can do
power m
something like this and
times
you
3
start
over
here and
here.
you want to end up here.
Fair, right? So you want
Yeah,
to
but
And
finish
now
yeah,
you
every
can
jump.
just decide where you do this and then you're done, like jumping and stuff.
Exactly.
You're,
And you
you're
go
going
like
to jump
this.
3 at some point and yeah, this
Yeah.
finishes.
Alright.
Wait,
Yeah,
so
let's
what's
do
the
that
solution
here.
exactly?
Okay,
It
so we
decide-
build this matrix
Wait, doesn't this
that is
finish?
numbered from
So you have
0
a 2 times m matrix.
all
Fair.
the way till m, right? And you have like
And
two
this is
columns
your
to this. This is 0 and 1.
V2 and this is your
So you
V3.
write, yeah, exactly, V2, V3. And
That's
now in a single step, you start at 1 and you have to end up here. And in one step, you can either skip a lot horizontally or you can go one step up. So if you just fix the movement where
fair.
you cross over, right, there are m plus 1 ways to do that. And now
Yes.
you'll find that the number of ways left for you is just 2 to the power something because you have those many ways of choosing the jumps here and those many
Yeah.
ways of choosing the jumps here.
Yeah.
Yeah, 2 to the 8 times 2 to the 3. That's it.
Right,
So
but
I
that's
think
a
that gives you
summation, right?
exactly the result.
M
So
plus
this is
2.
summation.
How is m
M
plus
plus
2
2.
there? Ah, why?
Why?
Wait, because you don't need to jump actually. You don't actually need to jump. You can like avoid the jump. You can jump and
Ah.
go horizontally at the same time.
You can jump and go horizontally at the same
Ah,
time.
right,
And you can
right,
even
right, right,
jump,
right.
go horizontally, do everything at the same time.
Yeah,
Okay,
can,
so
like,
you can just record the first time you jump or something. Like
Or
the first time
actually-
well,
you
jump
reach
is like
3.
weird. Wait, let's do
Okay.
this. Let's do this, right? Let's like take a path and then you have 2 to the something possibilities for every path. Or
Or
No, no,
but
no. I
that
think
is-
we're
so
done. Like, there's
basically,
very few cases left now. If you never make a jump, then
Yeah,
like
this
there'll be a
is-
moment where you make such like some kind of jump like that.
like any set of points is your path. Any set of points
Ah,
except for a set of points
exactly.
like this.
If
You
you make
cannot
a
go
jump
like
with a
this.
That
horizontal
works.
path,
Any
you make
set
a
of
jump with
points
a
that does not have a jump front and down, basically.
yeah,
You just need to go forward.
Yeah, if you don't have a jump, like if you're just making a jump with a horizontal thing, you can just count it as just going forward. And that's just 2 to the m minus
Yeah.
1. And that's just works.
The rigorous
what?
Like if you go with a jump and go forward, forget the jump and you're just going forward.
Like
And that should
it's
be
just
2
going
to the m minus
forward.
1. It's just going forward.
Wait, but then when do you okay? Whether you need to choose a jump at some point.
That's the first m plus 1
or
method.
consider all paths of k steps, and in a path of k steps, there are like k minus 1 possible ways to jump, to choose where to jump. So the
We can just set up the
path is
recurrence and, like,
determined by
finish.
just by v2, and so basically you get like summation of k times 2 to the power k, something like that.
And that is almost correct, I think, somehow.
Okay,
There
wait,
is-
now just regress that.
Wait.
So consider
I think we're failing counting here.
this is sad.
If you're choosing a path of k, the number of ways to choose the path is 2 to the k minus 2. No, 2
Yeah,
to the
and
n
now
minus
the
2.
number of ways to choose the path,
No,
where
it's
we're
n choose
only
k.
going to 2
Okay,
to the power
hold
n,
on.
like
Let's
leave
not
the
complicate
jump.
this, right? So let's
Yeah.
focus on like we're eventually going to jump, right? So let's say we do this at the ith place and we go to the jth place where j is at least I.
Oh,
Right?
but
So
the
you're just
problem is
summing
that
over
what
all
if we
I
made
at
a
least j
big jump?
from
Right.
0 to like 2m. Sorry, not 2m, just
Not
m.
just m.
M.
And you're going to go over all of these pairs, and the answer is going to be something like how much? You start at j and you have to go here. So how many?
And both are included. So
What's
2
you
to the
just
m minus j. 2 to the
No,
m minus
2
j
to
plus 1.
No, 2 to the m
No.
minus j minus 1.
minus 1 because
Yeah.
j and n are fixed, right?
Fine.
And then
Okay,
similarly, you
fair,
also
fair.
get 2 to the m minus
minus-
I minus 1.
I minus
Not
No,
I
to
minus
the
1,
I
just
No,
minus
I
I
minus 2,
just
I
I
minus 2, 3.
I minus
I
1.
minus 2.
Is there an easier
2.
way of counting
No,
the
I
same?
minus 1, I minus 1. Zeros
Same.
I
included.
minus
thing.
1. Okay.
I think fix I minus
So
j
this is 2
and
to the m
count.
minus I minus j. Sorry, m minus
Minus
j
2.
minus I. Plus
Minus
1,
2.
right?
Oh, just fix
Minus
j
2.
minus I and we can split
Minus
it into
2.
cases.
So
Yeah,
if
exactly,
we take out 2 to the
Yeah.
power m minus 2, then we're just looking at this sum. And we want to show that this is equal to how much?
Twice of m plus 2.
2 to the power
There's no
4?
double
No,
counting.
sorry.
What?
here, no.
No, what?
Twice of what?
We're supposed to say this is twice of m. Okay, this is 1 by this.
Yeah, it's 1 by
It's
like
minus j minus I. Yeah, this is twice of m plus 2.
Okay, that is more reasonable.
That's actually pretty good.
That's surprising.
What are we supposed to show it is
Yeah.
in the end? We need to show that it is
Hey, this is
2 to the
just
power
induction
m minus
Yeah,
1
I'm just
multiplied by
counting,
n
right?
plus 2.
This is-
You can
I mean,
induct
just-
this as well.
Just count, right? How many possibilities? Like
Okay,
Fine,
the
okay.
final answer we're supposed to arrive at is 2 raised to m minus 1 times n plus 2.
Yeah, so I think like we're basically done. We just have to show this
Huh.
little thing here.
so
Yeah.
it's like if
It's
you fix j
not-
minus I, then
Fix
we
j
have
minus I is
m
b
minus
and how many possibilities
d
are
plus
there?
1.
Yeah, like just induct on m.
Wait,
But the
is
summation
this
is
right?
easily the same.
Yeah, he's right. He's right. You should just induct on m.
yeah, I
Like,
think you
the
just get
sum-
like
There's a very small part that is missing.
You'll just get
yeah, I
plus 2
think
like directly.
I mean you just get plus 2 because the powers add up to that. I think.
Yeah.
What?
Wait, do you?
Just
Don't you lose out some small power of 1 by 2 to the power m or something?
You might lose out 1 by 2 to the m.
It is weird.
With this
I think the summation is easily possible to figure out.
Yeah, d by
Are
2
we
to the
doing
power d is what
something
they call
wrong?
an AGP
If
or
they're
something.
inducting, we could have like inducted like
Okay, we have
since the
issues.
start as well.
Okay, we have
Yeah,
issues.
if-
We have issues.
M equals 1 fails. M equals 1 fails.
Wait, we have an issue. I equal to 0, j equal
Okay,
to 0.
I think the summation
Oh,
is like
right.
slightly.
Wait, we have an
Yeah,
issue.
m
I
equals
equal to
1
1,
fails.
Something.
j equal to 1,
You
0.
have some slight issues like on the endpoints when I is 0 and j
Yeah.
is n. Then the
Well,
minus
Oh,
1
like
back
when
here
it's
is
a
not a
single
minus
jump
1.
from 0 to n. No, that's fine.
No, 0.
Counts.
Like when you 2 to the I minus 1, I is 0. It's just 2 to the.
Right?
It's
But
half.
it's like 1, but
Oh,
you're
shit.
counting a half.
Wait,
So there are some issues.
Yeah, that is a
wait,
issue.
yeah, why are they only 2 to the power I minus 1? It's not 2 to the power I minus 1 ways.
It is.
The reason.
It's 2 to the power I minus 1 unless I is 0, in which case it's 1
So
again.
if I is 0, then it's 1
You need to
one.
right?
recount.
So the
you need to
sequence is
count
like
yours.
this.
Maybe writing
Okay,
I is
sequence.
1,
Max
it's
of
still
I
one
minus 1
way.
comma 0.
Yeah,
Oh
1,
shit.
comma 1.
Okay,
The
this is
sequence is
very
this.
special
Like,
sequence
at
that
this
goes
at this at
1,
this
1,
point
2,
we should
4.
just
Okay.
we should just go back and induct it like
Yeah,
the
yeah, yeah.
normal way instead
Yeah,
of doing
like-
this
No,
parts and all.
That's too boring, I think.
We should just do
Come
this.
on.
No,
We
there's a
should just
clean
do
way to
this.
solve this. There's a clean way to solve this.
We should just do
Yeah.
this.
The direct induction just is works.
But where does the m plus 2 factor come from?
But where's the fun in that?
The fun in that is what is fun in this, like you realize.
Max to 5 minus 1 comma 0. Like.
Yeah.
Where is the fun in trig
Okay, so
bash?
let's just count. Why do you
Yeah.
guys like crying so much? We can just count I equal to 0 separately.
Yeah, and then I equal
And
to
J
m
equals N.
And J
And
equal to N
then-
as well. J
and
equal
Oh,
to
and
N.
then there's
subtract
like
J
4
equal to
cases.
m as well. Fair.
Yeah,
Now
there are
there's
4
4
cases. Yeah.
There's I equal to N as well. Like, don't do this, please. Let's just go to the induction normal.
No, I equal to m is fine. I equal to m is
I equal to n is fine,
That-
but like you also have I equal to
that-
0 and j equal to m. You have to subtract that one away.
correct.
Please,
Okay,
please.
Inclusion,
don't.
exclusion.
Archit,
Yeah.
don't.
It's 4 cases. Okay,
It's minus 2.
that's still pretty bad.
Why?
And now we just need to handle the cases where.
Or can you double count the sum in a different way instead of treating it in terms of I and j?
We need to do more double counting.
We'll do double counting double times.
Because
See, we'll
the
have to do a
first
sum
counting
anyway,
of the double
like-
counting are pretty stupid.
What are we doing?
Okay,
What
you
is
want to
going
jump
on?
from this part
Bro.
to this part.
Is there a double count that works in like just one step? Like
I think we should just get either we get a combinatorial argument directly getting the answer, or we're doing the induction normal one. Okay, no 4 cases, please.
No, we have to do
The
this. like,
combinatorial
hybrid
thing, directly getting the answer, that's far superior. Oh, someone check the comments on the YouTube thing.
let me check.
What?
Some very interesting.
What is that? No, I am not in Sri
What is
Chaitanya
that?
at all.
No.
What? I am not in Sri Chaitanya.
Okay, now that is jumping to me.
And like, don't spam the chat, please.
Yeah, we need some moderator to do something.
Yeah. Someone is a moderator, please don't spam chat.
Oh, okay. Can we treat a jump as an x coordinate and a y
I
coordinate?
just
So,
do it. Come on.
yeah. So your jump is either k comma 0 or k comma 1, and you want to partition m. You want to partition m into numbers, into like let's say k things, and there are k possibilities of where your y coordinate of 1 comes. Right. So it's basically number of partitions of m into.
Partitions of m.
Okay.
Already
also-
Partitions of
complicated,
m into
bro.
k.
Also, we have that like 1 and n are fixed, but you can jump at n.
Yes, exactly. So
Doesn't
So,
this just correspond
like
to
leave the jump of v3. If it was only 2 to the power m, then
Then it
how many
directly
ways would
corresponds-
there be of jumping? There just be simply 2 to the power m minus 2 ways of jumping.
Yeah.
Right.
That's like
And
for any
now-
subset you can just do it.
Yeah,
Yeah.
for any subset. And for any subset of k jumps, if for any subject of k jumps, there are k possibilities of where you make that
No, but
step
can't you
up.
do it at 0 or x as well?
You
Like, sorry,
actually have-
0 or...
No, wait, actually,
wait. This is actually much easier.
Yeah.
You don't have k, you just have m plus 1 choices at every size step, right?
But
Except
no.
there's a choice.
Any
of going
point you
up
can just
also.
go there. At any
No,
point,
No,
you
but
can
you're
just
not
break.
necessarily going to go one step up now. You might go somewhere random.
Wait, let's
Huh,
do
that's
it
what
like
I'm saying.
this.
That's all
Start with
counted
a-
in that. That's the
Start
thing.
with a partition, pick any point, jump at that point. That's it. Shouldn't that
What?
just work?
Why?
Start with
And also,
the
like the answer is m plus 2. We don't have m plus 2.
yeah. That's the
No,
Wow.
but the
M plus
point
2
is you
is
might have
fine.
repeats there. Like if
Yeah.
you are planning on doing something like this and then taking some point and moving all of things after that,
Yeah.
you can't actually do that because like you might actually repeat. So you need to count those
Okay,
cases
let's
separately.
do it like this. Let's do it like this. We are going to choose the
Okay,
number
but
of.
I think I see
number-
what they're doing now.
Okay, no, that's
If we
So
were
every
actually
stage-
writing
Okay, let's do it.
RMO today, how long would it take us?
Wait, let's do it like this. Okay, like if you are at cell,
No, not too long.
like if you are at a cell over here on the bottom row, then we are we assign numbers like these 1, 2 up till m. But here we have 2, 3 up till m plus 1 or something like that.
Okay.
But you
So
can't
it's a
jump
increasing
from 3 to
sequence.
4.
Yeah, that's so like we're going to choose a sequence from 1 to m plus 1 and then just arrange it somehow. Yeah, we're going to choose a sequence from 1 to m plus 1. And then we can just jump at any number.
You have m plus 1 choices, not m plus 2.
Yeah, okay, we just need a one more number somehow.
That is exactly what I was saying. But why is m plus 2 coming?
Nice.
Okay, let's say we're choosing k numbers from 2 to m minus 1.
I think we're coping very hard here.
Well,
Yeah,
Dude,
this is
we're
looking
coping
right.
super
K,
hard here.
k numbers from 2 to m we are choosing, right? Other than 1 and m plus 1.
Okay.
And then we just choose a number to jump at.
Yeah.
Right.
Yeah, the point is you can choose
That's
any
correct.
point to jump at. and
M
that
minus
should
1
work.
choose k into k plus
Into
1.
K, that's
Plus 1.
It's
We can
not
jump at
K.
into K
m plus
plus
1.
1. But
No,
except
we
the
can't jump at m plus
place where
1.
we,
M
if
plus
we
one
It's
is always
not
choose
jump.
really
jump at
K.
point 0 or point M,
Okay, but there are
is there
two
a special case for
possibilities.
that?
There are two
Oh wait,
possibilities.
we
We
never
never jump.
counted.
There are two possibilities. We
Oh,
never jump. And we
that's the
just ended
case
m
as
plus
well.
1. Yeah.
Bro,
Like we
that's
and
the case
directly
as
ended m plus
well.
1.
What's the case where we never jump?
Like directly going to m plus 1. Like the jump is at m plus 1 directly.
Yeah, and the case where the jump is at 0.
You can't jump at 0. You have to start at 1. And then you jump at 2, then you're doing 1, 2.
Yeah, you go 1, 2 directly.
So
that's the
the jump
case.
is at 2. The jump is
That's
at 2
fine.
in
okay,
that
like
case.
that.
That
Okay,
still
okay,
should be
okay.
fine. But still,
So-
you have 2 to the m minus 1 cases.
So I mean, like the summation is this, right? Summation this plus 2 to the m minus 1. Great.
M minus
Right.
1 choose K times K.
Wait.
Is this
No, no, no. It's not K. It's m plus 1. You can jump at any point.
No,
You
no.
can even jump
Like
in
we jump
No,
in
between.
a
if there
sequence.
are
No,
K
no,
jumps,
no.
then there are K ways of jumping. That's
I,
correct.
if we're going to sum anyway, we might as
I mean, like, does this not work? Like,
this is correct.
Doesn't receive m plus 1.
But is it
Yeah.
M minus 1 choose K or M choose K?
Like
I'm not.
the point is
I
this.
think-
The point is this. Like we have a k element sequence. We're going to have a k plus 2 element sequence, right?
Yes.
We just read out the numbers in this grid.
Yes.
Okay.
Yes, we have a K plus 2 element
You
sequence.
have k
Exactly.
choices. You have k choices for
And
that sequence
we
of
have-
numbers.
And in those K middle places, no, actually, there are K plus 1 possibilities for the jump.
No,
Because the
no.
last one could be the jump.
Yeah, but
Last one could be a
that's
jump,
this.
right?
That's this.
Okay, so that is counted. Then there are K possibilities for your jump.
Yeah.
Yeah. And
And this summation is known something, right? Or is it not?
yeah, we can
this
just
summation is
manipulate
known.
this
This is
summation.
just m times 2 to the m.
No, it's m minus 1 times 2 to the m minus 1.
अरे whatever भाई 2 का constant इधर रह गया. Something
Yeah.
like
And
that.
that's not right.
Yeah.
Wait,
let's
no,
just
isn't that M minus
I
2
think
choose
I think
K
let's just stop
multiplied
and let's
by
just induct and
something?
just get
Yeah.
away with this. You
Let
know.
us induct.
I think this is
What's
the
wrong with
safe path.
inducting?
Yeah. What's
Yeah,
wrong with
I
inducting?
agree with Kanav now. We should just solve the
No,
problem.
now you're fine. Now it's fine.
Like so, Vishal in chat is like, imagine not inducting.
Yeah, let's just induct. Let's just go back to this formula. Okay, where was it?
Yeah.
Yeah.
This formula.
Can we cut this? Like, can we cut this part of the stream?
Which formula are you guys?
It's already live.
Come to the summation part.
Let's add a domino at the end.
Like,
Interesting.
just copy paste this
Wait,
formula.
so are we just inducting now? Do we
Yeah,
just
let
use
us
this
induct
formula?
this.
Let's
Let's
get
just
that
use this
formula.
formula. Induct.
Which
that.
formula are you guys using?
Like, Kanav, are you putting in there?
I'll put it 1 second.
Let me follow you.
Okay,
Yeah, this is the formula. We're just done with
formula is
this.
extremely horizontal, not horizontal, so I'm missing out.
Okay, let's first calculate f of 2 to the power n.
It's 2 to the n minus 1.
Very good.
Should be
Or
n minus 1.
Or 1 if n is 1.
Yeah.
Okay,
But
fix
there's
the
separate
formula.
case.
Why is this so annoying? This is a bad problem.
Yeah.
This is a good problem. This is the only good problem in the RMO in my opinion this year.
So what we need to check is this. That's all. Is
Pick
equal
some way to
to
check.
2 to the m, I believe. So
Should be
that's,
Oh yeah, that actually sounds 2 to the power m because
because like the
of
plus
that
1
offset.
and the plus 1 also that helps actually. This plus 1 is improved. And this is 2 to the I minus 1 I plus 2. This all we need to check. That's all.
Wow.
What are you doing?
Also,
What
is
were you
I equals 0? Just check if I equals 0 is valid, because in the problem they said for m
Okay, no.
positive integer, and I
So
think
I
we
minus
have
So
one
this
and
is
I
true,
zero.
right?
Wait, no,
So you
no.
have
Okay,
2
okay,
to
wait,
the-
wait. No, no.
Wait. Slow
Wait,
down.
wait.
Slow down.
Plus
Slow
of
down.
3. whatever f of 3
Yeah,
is.
there's
I
an
don't
f
know.
of 3 and this f of 1 doesn't exist, right?
And what's f of 3? F of 3 is also
F of 3 is
1.
1.
So
F
a
of
1.
3 is 1.
Yeah, is this right? Yeah, everyone.
I
Yeah, it is
think
right.
so.
It's right.
Okay, so we get 2 to the power m plus 1 plus,
What m plus 1?
because like,
The plus 1 is below.
yeah, no, I'm talking about this sum. This sum is 2 to the power m, na? This times I by differentiation or whatever.
See, so
What?
Wait,
Differentiation?
differentiation.
True.
No, you
Wait.
can treat it as multiple powers and then
That's
add them all
false. Like
again.
if you have
Bro,
2
like
x
if you
to
have I
the
equal
I,
to 1, this is like 2 to the m only.
if you have this,
Yeah, I think it's 3 to the m.
Yeah, I
Okay,
think it's
what
something
what
like
is
it.
this sum evaluate as?
Yeah, the thing is
Yeah,
like
like that's what Achit is doing. You take the polynomial and differentiate it.
What
if
would
you
you
Yeah.
differentiate?
differentiate it,
Okay,
it
wait,
it
there
uses
is
t
a
prime of 1, and this is equal to x to the m,
there-
and you
there's
could
an
like
easy
include
way
0
to
because it doesn't
But
matter.
I don't think
evaluate
it's
this
2 to the
it's
m.
like this.
It's probably m into 2 to the m or something.
Okay.
And
yeah,
so
it's
like,
m into 2 to
what do
the
you
m.
get?
It's m into 2 to the m.
Yeah.
Oh, okay, cool. Okay, so that
I-
gets us
like,
the.
is it confirmed m to 2 to the m?
Wait, it can't. It shouldn't be m times 2 to the m. That's way too big.
Yeah.
No, I mean, like, how do you get this m times 2 to the m over here then? M times 2 to the m minus 1 part over here. How do you get that?
So you're
That's
just
the only way I'm
assuming.
going to get that.
I mean, if you
it has to
differentiate,
be something like that. I don't. Not complicated.
I think we should just do this. Someone differentiate this with me.
Someone differentiate. Okay, wait. I can actually like let's just find that out. So 2 to the power I minus 1 to the power times I. So you have 1, 2 to see. Just we treat it something like that.
Okay,
Is
and
this
now
correct?
plug x equal to 2 here, right? No, 1.
Yeah.
no,
No,
2, 2,
2.
2.
Yeah,
Ah,
like
2.
x equals 1.
So m times 2 to the m minus 1 minus
This is this thing.
2 to the m minus 1. Yeah, there we go. That's the sum.
But okay, but the
Ah.
summation, our summation is ending at less than
Yeah,
m.
so this 2 to the power m will cancel off with it, and you'll get m times 2 to the power m minus 1, which is wrong.
It's less than m.
What?
The summation ends at m minus 1. It's from I to 0 to m minus 1.
So
Are you
it's
considering
m
that?
minus 1.
Okay, no,
m
you are
We
minus-
considering that.
we
You are considering that. Yeah,
we
you are
that.
considering that.
Oh, we are
It is.
yeah, that's fine. So this
Wait,
is
so
the
what's
sum.
wrong?
Have
Isn't
I
it all right?
differentiated wrong?
Wait,
Check
this is
that.
I plus 2, so there are also
Wait, let's not
some
differentiate.
things.
Let's just do it in a natural
Differentiation
way.
is so overkill for this.
Yeah, like,
I think it's the morally correct way to do this because like
Morally
Morally
correct way
correct.
to do this.
Wait, why?
Yeah,
Wait,
yeah, yeah.
this just why are we not doing this? Like, we have a factor of this as well, right?
Did we take like double the time for P6 than 1 combined?
we're like we're trying not to do the right.
Let's do the morally correct way in that case. Trying to get things through.
Okay, it's this.
Hey, wait, we
Wait,
are
guys,
done, right? We're done.
This is
What are we
words.
doing?
What are we doing?
If you just treat
Yeah,
it as
we're
a
done.
matrix and
is
add
correct.
it like a triangle.
Yeah, we're done. We're
instead
done.
of
The plus
Wait,
2
it's
factors also
having
exist,
different-
right?
Wait, it's
Yeah.
minus 1. I think it's minus 1 here. It's minus 1 here.
No, it's not.
No,
No,
It
it's
is.
not minus 1.
It is.
In that
That's
case, you
what-
get
It works,
M
right?
plus
Because
1.
wait,
Yeah,
let me copy this. Let me copy
I
this.
think
and-
it
Wait,
works.
are you
I
sure
think
it's
it
at minus
works.
1? Are you sure it's at
I
minus
know,
1
no,
over
it's
there?
not minus 1.
Like, look at
Yeah,
this.
so
Look at where
wait,
I
wait,
am.
let me write again. Let me copy. Can someone copy that expression? Okay, we had something like we have like 2 to the power m
Sure.
plus m times 2 to the m minus 1 minus 2 to the power m plus 1 plus
Correct.
sum 1 less than or equal to I less than m 2 to the power I plus 1, right? So this will cancel.
Into
This part
yeah.
will become a 2, and now it's like 2 plus 2 all the way till 2 to the m minus 1, which is equal to 2 to the m. And when you combine that with this, you get m plus 2 times 2 to the m minus 1.
Okay, so it works.
Yeah, this was always working. Yes,
Yeah,
induction
I mean,
was,
induction is always
is-
working.
induction was superior than path counting.
Yeah, but I think path counting is like the only way you can try to hook for
Path
some
counting
kind
is the
of-
most intuitive way to think about this. The summation
Ah,
part.
yeah.
I mean, sure.
So we are done.
Yeah.
So we are
Yes,
done.
yes.
Also,
I think we're done with.
Yeah,
P5
we-
has a one-line solution. It's Ridgel's problem.
No way.
Wait, what's the one?
I mean, if the one-liner is your high school.
Is it like
ID,
some? Is it like some random? Not random, but like is it some POP?
I don't
degree
know.
counting?
I don't know.
P5 is the geo.
P5 is a
Yeah.
geo.
Yeah. How do you have a one-line solution to that? Interesting.
Probably some very like Tolmie or something.
I mean, our solution is it? I don't know.
Our solution can be like in one line, you know.
I mean, but imagine saying AC plus BD when their diagonals are strapped together.
But AC is equal to BD. Like,
Exactly, that's the
Yeah. So,
okay,
so you get
the
the two
problem
times
itself when you
business.
look at it, it's ugly.
Okay, I think we can even entertain any doubts people may have.
Doubts.
Doubts about the cutoff, firstly.
No, about the
Cutoff.
problems.
I don't
What
think-
do you know about cutoffs?
I've never done RMO myself. I don't know what cutoff's gonna be like.
I don't
I think neither of us have done RMO.
Yeah, none of us have done RMO.
None of us
Yeah.
ever wrote RMO. Yeah. I think
Even I
Malay.
have never. No,
Oh,
no, I
Malay
never
never
wrote
wrote it.
RMO.
Has anyone wrote RMO
Yeah.
themselves?
You want? Oh yeah.
Further questions.
Yeah, I'm checking YouTube.
Says, can you pin the question you were solving?
We're not solving any question right now. We're done with all 6.
We're solving question 6. Maybe you can just share all the questions. In the
Maybe
end.
write the solution slightly neater this.
How long did the last RMO live solve take?
I don't remember. It didn't happen.
It didn't
time
happen.
we
It didn't
just
happen.
we just did
We just
videos.
uploaded
I mean,
videos.
this was like we were done in 30 minutes, but the last one we just spent 20 minutes for no reason.
Yeah.
Did not induct for some reason.
Cutoff prediction, guys. Cutoff.
I think we were trying to be smart and get a one-liner combi tutorial.
One-liner combi ended up in a. Yeah.
Should have done that.
Unfortunately, it turns out algebra wins every single time.
You cut off last
Cutoff
year. Was
prediction.
great. I don't even remember last year's paper.
What do you know last year cutoffs?
He's like, I think they're asking like compared to last year, how much would it change? Like,
What is
I
last
don't
year's
remember
cutoff?
last.
I think
don't remember the
cutoff should be
paper.
high only. Probably, right? I can't
What?
imagine it will be low.
How much
Yeah,
was
like,
last
I would
year?
say this year's cutoff should be like 3 problems.
I don't know.
Ah,
What was
I
your
think
How
last
much
year?
was last year? Does anyone
More
No, I
have
think
any
last
idea?
year was 3 problems as well.
In that case,
problems.
4 or 5.
Yeah,
5
4
Five
problems.
is like
5 is never
too much.
happened.
I think-
5 can
I
never
think-
be a
Nah,
cutoff.
it's not. It's not.
Someone is saying
won't be
last year
that.
RMO cutoff was 17 for Telangana.
Okay, depends on state.
Right,
also,
state-wise.
Okay.
Yeah.
That's very
Yeah, I don't think
okay,
it's gonna
yeah.
be more than like 30.
No,
then,
what
for sure.
what is the national cutoff?
It
The
doesn't
one they
exist.
have for
National cutoff
everybody.
doesn't exist for RM.
It
So
exists
there's
for
some states that
IIQ.
have cutoffs like
It exists for IIM,
Kerala
not
has
for
a cutoff
IIM.
like 3 and 4. Very weird.
Like, if it was 17 last year, then
Yeah,
there's
but
no way
okay,
it's
if you
gonna go
look
more
at
than
like the
30.
more competitive places, I don't know, like
Right.
Mumbai or something.
No, take Delhi for example. Very competitive.
What would be the cutoff here? What was it last year?
There's-
I don't know what was the Delhi cutoff last year.
Nobody knows. But
I
yeah,
would say apart from 3 and 6, you should be able to solve all the problems like fairly easily. Apart from 3 and 6, yes.
but 4.
4 is like
4
Yeah,
was a
4 I
did-
think.
A1, A2 problem.
you guys
right?
did
Okay.
something nonsense, but like the normal solution is like
Yeah.
straightforward.
yeah, actually,
think
correct
1 to
is
5
correct.
Actually, I don't know. Like, 2 is maybe not that easy, right? The n by 2 idea.
If you get the size idea, then let's say like manual checking, maybe time sync.
Maybe
Like
you should
the
like compare with the last year's paper, maybe something like that.
Yeah, you can compare with last year's paper. I don't know.
So P1 was,
Yeah.
I guess, similar.
The P1 was
What
just
was last
nice
year's P1?
started.
like
Can
mod
someone
2,
see?
mod 3.
P1 was at A square plus B square.
Yeah,
Okay, yeah, fine.
that's similar to this P1, I guess. And
Maybe the part B of this is slightly harder.
I think the two geos, like there was one easy and one hard, like one harder one, and I think they
wait,
matched.
there was
like
one geo last time.
Right.
there are two, I think.
What?
Wait, let
P2
me
was the
just
only geo, right?
One was the fake geo, which is just fact 5, but you twist it and turn it. Something.
Yeah, there were 2 geos.
But P5, you need to remember to do it, Bash, if you want to get it correct. I think most people should have done that.
Yeah, I
and
think 5.
last year P3
5
had the
is
sum
like
of digits
everybody
thing.
should be able to do 5.
Yeah, okay. Last
Yeah,
year
there
I
was
had
a fourth
okay.
power. Fourth power, sum of digits.
Okay, last year
the
at case
square.
batch. This year it doesn't. So
Yeah, last year was
Yeah,
like
that's
horrible.
good,
You had to
that's
check like 30 cases.
yeah.
I think
Yeah,
2 can be
yeah,
a case bash, now. Like 2 is sort of like a case bash. You have to check.
I
1
mean,
to
10 point, 10
No,
numbers.
10
That's
and
a-
30 have a
fine.
difference.
not 30. Like I think it is okay. 36. I think
Yeah,
that's
but
around
also
30.
they were not doing simple stuff like mod 9. If you do that, it already cuts it down by a factor of 2
No,
by
no.
9 or something.
No,
We
no,
do
it
mod
does
9
not.
and then get 30. It's originally like close to 1000.
It's like the
Yeah.
amount of optimization you end up doing, you still have like 30 cases left to check.
Yeah, you start with 1,000 and then you reduce it to something like
They
that.
Wow.
I don't
they should
remember.
allow
Yeah, I
the
think there was
use
a
of like
36 good.
Yeah, yeah. And like you had huge solutions as well, so you can't skip cases.
Yeah. You had like some random 36-24 solution, something like this.
yeah.
But I think overall this year was slightly easier than last year.
I'm pretty sure I've
On
skipped
the
4.
easiest side.
Like I think 4 is like
Yeah,
one
4.
Yeah, but I think 4 is like
Like I remember doing it in NMO.
No, I remember writing a solution to this on your PS some thread.
Wow.
Maybe the constants were different, but the trick was the same.
No, P3 is like hands on the best problem in this RMO. So 23
Yeah,
is
P3 wins on the
beautiful.
statement, man. 23, bro. 23.
23
That's
HP, that's
fucking
such a
it's
beautiful,
relevant.
Like,
that
why
is
couldn't they make it 24
incredibly
something?
beautiful.
I mean, it's not true.
It's not true.
They should have made the test last year, basically. Then
In 2023,
Ah.
that's sad.
That's smart. That's
I mean,
smart.
2 OD is equal to 0 to
23
3 HP.
HD. Then centralize an encircle. Like that is like
That's
best statement in existence.
Yeah.
P3 is
you've
beautiful.
heard of
P6 is
24 inch
also very nice,
HD
actually,
displays,
except
but have you heard of 23 inch?
if P6 had an actual combi solution, that would have been nice.
I mean, we almost,
Yeah.
but
If
we're
you
just
find
missing a lot
one,
of cases. We're just missing a lot of
Apart from
cases.
Like the
induction
edge
case.
cases are like edge cases are like just
Too many.
create havoc.
No, I think it's just a summation that's pretty easy. We just mess it up by differentiating and stuff.
We didn't differentiate the summation.
Fine.
We
Yeah,
did
just
differentiate
case.
in the end to calculate that sum. Like,
To calculate 2 to power I minus 1 times I.
You
Okay.
don't need to
yeah,
differentiate for that.
You
like
don't need to differentiate for that.
what do you mean? You don't need to, but you should.
Why?
You'd be better off not doing it.
No. I really disagree with
I mean, P1 and P2 are just there.
Like still, I don't
you. I think
think
P2 is
more
like
than
still a
30.
little non-trivial, maybe.
You just
Like,
need to remember.
but P1
N squared
and
stuff.
P5 are certainly very doable. And I think
If-
one
If
of
you're a
2,
computer
3,
science
and
person,
4.
you might have got P2 fairly easily. If you remember that, like, R of n is order of n squared, then you can easily bound by size. A lot of things in the case bash for the rest.
I think like even for this, if you check a lot of numbers, you'll probably see the pattern of like numbers just decreasing at some point. And
If you write down the reminders, yeah, just see
yeah,
like
if you
4,
if
3,
you
2,
like
1.
start
Exactly,
checking the
exactly.
cases of 1 to 9, that already gives you like 4, 3, 2, 1, 3, 2, 1, and that like gives you some idea on what's going on, and you can centralize on
Yes,
that as
true.
well.
Yeah.
How was last year's
Okay.
P2?
Last year's P2, it was that fake geo. It was fact 5.
So I think we should stop now.
Yeah.
Yeah, I think that's
Okay.
Need
Uh,
anything
That's
else
all
in
you want.
chat?
Okay, so goodbye, chat. It was fun doing this stream. Probably.
Nothing else, right?
I
Yeah,
don't think
so I'll
so.
just end it.
Yeah, I think
Yeah.
we discussed all problems. I mean, maybe we could check one last time if people have anything else to say.
Thank you so much.
I
It
can-
says, any other doubts? If you forgot to write one, how many
One.
marks deducted for P2?
Wait, what do you mean?
Like
max
solutions are 1 and
like
5.
1.
The answer
Yeah,
is
like
1
I'd
or 2
say
or something.
Like probably
I mean,
16 or
if you
like, okay,
proved
fine.
your size
know.
argument and you still forgot
Then
to
I think you'll get like
give the correct
13 or
answer. I mean,
But
maybe
if
the
you
construction
just
is
said one
worth
works
like
and
say
then you
8.
claimed nothing else works.
Let's say 12 or 13.
Positive. How many marks before?
I don't think that's a good question to ask because we have like no idea on how what
The
marks will
cutoff
be
for
given.
specific states is
Yeah.
again hard to tell, but like
Yeah, I think there's a
maybe
lot
like
of variance depending on what
maybe
state you're
multiply
in.
a past year's cutoff by 150% should be pretty
Not
accurate.
150.
150%.
No,
150 is too
no.
high.
Yeah.
I mean,
No,
2
no.
should be
I'll
okay.
say
okay.
like cutoffs are just
145
too
and 30.
hard. Like cutoffs are just too hard to
Predict,
Yeah,
yeah.
like estimate.
Predict.
Like
Actually, I've seen in real life
estimate.
that usually when you predict a cutoff, it often comes down lower than you expected it to be for some reason.
Yeah. That's always true.
Like INMO 2023 or something, like you never expect a cutoff of 19.
So like also like I think like only P3 and P6 are probably harder last year, right?
Yeah.
Where others easier, right?
And P6, it depends on how hard the other approaches are also.
I mean, the last year
No, I meant like last
inequality
year's P6.
used AMGM. This inequality doesn't need any AMGM. It's just like
I mean, it needs smoothing ideas, so you can say.
no smoothing ideas, bhai. It's
No,
like
that
It's
no,
smooth,
it's
but
like
quadratic, bhai.
I mean, it's
Expand.
smoothing, but it's still smooth. Like, it's still
Like,
like
Wait, what do you
smooth,
mean
right?
quadratic? Like the
I
distances are
don't.
like only
you
bigger
should
than
expand like
1 millimeter.
quadratic. That's it.
Yeah, that works. Like it's like
But it's still
No, I
sort of
still
like a
feel the
smoothing
other
idea.
solution is superior. Like you order
I mean,
them and then you get that estimate of j minus I whole squared by 5. Like it's cleaner. It
sure,
has more.
sure.
anyways, I think let's
Okay.
stop.
Yeah, I think we
Yeah,
can
that's
stop
it.
it.
Yeah, I'll end the stream.
Goodbye.
Goodbye.